Hello everyone. Today I am going to explain a problem of design of pre-stressed concrete section, that is Module 3 of PSC. A post-tension PSC beam 300 mm wide is to be designed as a rectangular beam to support a UDL of 20 kN per meter over a supported span of 18 meter. The stresses in concrete must not exceed 16 MPa in compression and 1.2 MPa in tension at any stage of loading. Assume average loss of pre-stress is 17%. Design the beam, calculate the depth, pre-stressing force and eccentricity. Here it's a post-tension PSC beam having a width of 300 mm. About the depth, they have not mentioned. We should design the depth. So they have clearly mentioned it's a design problem. And simply supported beam carrying a UDL of 20 kN per meter and length of it is 18 meter. We have a stresses in concrete which should not exceed 16 MPa in compression and 1.2 MPa in tension. Then average loss of pre-stress is 17%. We should find out how much is the depth, pre-stressing force and eccentricity. I have marked that. So while starting the solution, we should write all the given data. Width is 300 mm, WQ is nothing but a live load of 20 kN per meter, length of the span is 18 meter. So let us find out the moment due to live load. Notation is MQ. For a simply supported beam, the moment formula is maximum moment formula is which is carrying UDL is WL square by 8. So here we know WQ. So for MQ you should take WQ live load value. WQ into L square by 8 is 20 into 18 square by 8 will give you 810 kilonewton meter. Convert that it into Newton mm. It will be 810 into 10 power 6 Newton mm. Next is dead load calculation. Here we know notation for the dead load is Wg, that is given by cross section into area cross section into density. Here density is 24 kilonewton per meter cube, and we already know the cross section. Here only the width is known, depth is not known. So I have taken it as 300 into h into 24 by 10 power 6. How did I get this 10 power 6 is 300 and as well as h is in mm, units are in mm, but this density is in kilonewton per meter cube. So I have just converted this width and depth into into meter. That will be 300 into 10 power minus 3 h into 10 power minus 3. So minus 3 if I write in the denominator, it will be 10 power 6. So it is 300 into h into 24 by 10 power 6. Wg dead load is 7.2 into 10 power minus 3 into h into kilonewton per meter cube. Kilonewton per meter. Now still h is unknown. The next calculation is moment due to dead load. Moment due to dead load formula we have written Wg into L square by 8. WL square by 8 is for simply supported beam carrying a UDL. When simply supported beam is having a UDL, the formula should be WL square by 8. I have considered that. But while considering this W value, you should be careful with the calculation. Just copy down WG 7.2 into H into 10 power minus 3 into what is the length of the beam? It is 18 square whole divided by 8. Mg is 0.2916 H 10 power 6 Newton mm is a answer. Beta or efficiency is equal to 100 minus 17. 17 means already they have given, you can go back and check. They have clearly given assume average loss of pre-stress is 17%. That only we have considered here. So 100 minus 17 percentage, 100% minus 17% will give you 83%. That will be equal to eta is equal to 0.83. Next is a conditions given. What is this FTT means? It is tension at transfer. FTW is tension at working load. This FCT is compression at transfer. FCW is compression at working load. So in the question itself they have mentioned the stresses in the concrete must not exceed 16 MPa in compression. 16 MPa in compression means in first I will tell you about the tension, and 1.2 MPa in tension. In PSC, tension means it is negative. So it is FTW or FTT will be minus 1.2 MPa. Compression is positive. So FCT or FCW is equal to 16 MPa. See here, tension is negative. In PSC, tension is denoted by negative sign, so minus 1.2 MPa for tension. Next, for compression, it is 16 MPa, that is positive. Okay, we require these notations for the formula, that is section modulus for working condition. This ZB is nothing but section modulus for working condition. That is equal to mq plus 1 minus eta into mg by eta into fct minus ftw. This is a formula for zt. That section modulus should be equated to section modulus of rectangular section. For rectangular section, formula is b h square by 6, or you can take it as b into d square by 6. Okay, h it can be d or h, both are same. So equate these two formulas and find out how much is a h value. We know all the values, just substitute all these values. mq is 810 into 10 power 6 plus 1 minus 0.83 into mg is 0.2916 h into 10 power 6 whole divided by eta is 0.83 into fct is 16 minus ftw is minus 1.2. Substitute everything here, but when we come to this formula, h is unknown, but width is known, it is 300 mm. Take 300 into h square by 6. After simplification, we will get this equation equal to 50 h square. Still simplification is done, we will get the equation. So if we solve this equation, we will get h as 1092.51 mm. That should be rounded off to 50th value or 100th value. So what I have done is I have rounded off it to 1100 mm as a h value. It's up to you. You can go for rounding off to 50s in hundreds. So this is a value of h. Okay. Next is cross-sectional dimension of the beam. Already width was known, B is 300 mm, depth we have found out, D, capital D or H both are same, is 1100 mm. So area will be B into D, 300 into 1100 will give you A equal to 330 into 10 power 3 mm square. The next thing is section modulus at bottom and at the top. So ZT is equal to, ZB is equal to B into H square by 6 or B into D square by 6. That is equal to, convert, I'm sorry, there is no conversion here, directly just substituted B in terms of mm and even H in terms of mm. So after solving, we will get 60.5 into 10 power 6 mm cube. Next is mg. mg was in terms of H. Now we know H value, substituted, we will get mg has 320.76 kilonewton meter. Don't forget the notation. mg stands for moment due to dead load. Next calculation is calculation of pre-stressing force. Pre-stressing force formula is B equal to A into ZB into F inferior plus ZT into F superior whole divided by ZT plus ZB. So we required all the terms for this formula. So we should find out how much is F inferior and F superior. So you can see here, superior means at the top, F superior equal to FTT minus mg by ZT. Now we know all the values. Be careful here. FTT should be substituted with the sign. As it is minus 1.2, substitute as it is minus 320.76 into 10 power 6 divided by 60.5 into 10 power 6. So F superior is minus 6.5 Newton per mm square. Next is F inferior. The formula for F inferior is 1 by eta into FTW plus mg plus mq by ZT. F inferior is 1 by 0.83 into minus 1.2 plus 320 into 10 power 6 plus 810 into 10 power 6 whole divided by 60.5 into 10 power 6. So F inferior is 21.07 Newton per mm square. The P form, as I told, we required all these terms. Now we are ready with all these terms. So P equal to 330 into 10 power 3 into ZB is 60.5 into 10 power 6 into F inferior. You can see here it is 21.07 plus ZT 60.5 into 10 power 6 into F superior is minus 6.5 whole divided by ZT is 60.5 into 10 power 6 plus 60.5 into 10 power 6. As ZT and ZB are both are equal, we will get same value. P is, that is pre-stressing force is 2404.05 kilonewton is the answer. They had asked us to find out depth, pre-stressing force as well as eccentricity. We have calculated the depth, capital D or H both are same, we have done that. The second thing was to find out pre-stressing force. It is around 2404. The next and the final thing is about eccentricity. So how much will be the eccentricity? The general formula is E equal to ZT into ZB into F inferior minus F superior whole divided by A into F superior into ZT plus F inferior into ZB. Substitute all the values. Here, why did I write this square is as ZT and ZB is having same values. So, it is whole square into 21.07 minus of minus 6.5. A is 330 into 10 power 3. F superior minus 6.5 into 60.5 into 10 power 6 for ZT plus 21.07 into 60.5 into 10 power 6. This is a value. So, eccentricity will be 346.51 mm is a eccentricity. This was the last thing to be found out. We have done that. All the values we have got. So, like this we should solve a problem, or we should design a problem of flexural strength. Thank you.